We've discussed molar masses, stoichiometry, Avogadro's number, and formula mole ratios as the 4 different ways that you might be asked to convert moles to something else. It's unlikely that you'll run into many problems on an assessment that solely ask you to do one of those things. More often what you're going to find is that a problem will ask you to incorporate multiples of those and in order for you to actually solve the problem. So this video does 2 examples of the types of problems that build in different parts of these mole conversions that we've worked with. If you haven't watched the videos on those 4 individual topics, you'll want to start there first. In our first example, we have 30 grams of aluminum reacting with iron 3 oxide to produce aluminum oxide and iron. Right there, I see that I have a chemical reaction occurring, and I'm probably going to have to write out and balance the reaction. I finished reading the problem. It says how many grams of aluminum oxide are produced. So it tells me I've got 30 grams of aluminum that's present as a reactant, and I want to know how many grams of aluminum oxide are produced. So I'm going to write out and balance that chemical reaction. It tells me aluminum reacted with iron 3 oxide. So that tells me I have aluminum plus Fe2O3, and it's reacting to produce aluminum oxide, Al2O3, plus iron. And then I need to balance my chemical reaction with 2 aluminums and 2 irons. Once I have that started, I know from this balanced chemical reaction that I have 2 moles of aluminum and 1 mole of aluminum oxide. So that tells me I've got this relationship, 2 moles Al are equal to 1 mole of Al2O3. The question starts by asking me, or giving me 30 grams of aluminum. So I'm going to start there, 30.0 grams of aluminum. And anytime we have grams, we know use the molar mass to change to moles. Plus, I know that I've got this conversion up here, which is in moles, so it makes sense to change to moles. So I use the periodic table to figure out the molar mass of aluminum. It's 26.98 grams per 1 mole of aluminum. That allows me to cancel the grams of aluminum, and now I'm in moles. I know that I want to be in moles of Al2O3, though. So my next step will be to take that 2 moles of aluminum that I had from the balanced chemical reaction and set it equal to 1 mole of aluminum oxide. That allows me to cancel the moles of aluminum. Now I'm in moles of aluminum oxide, but the question asks me for grams, so I need the molar mass for 1 mole of aluminum oxide, and that is 101.96 grams of Al2O3. And when I put all this into my calculator, I get 56.7 grams of Al2O3 as my answer. So you'll notice in this problem we used a molar mass here, and we used a molar mass here, and we also used the mole ratios from the balanced chemical reaction. In example number 2, I'm asked to find the mass in grams of a sample of carbon dioxide, which contains 2.70 times 10 to the 25th atoms of oxygen. What I notice here is I don't have a balanced chemical reaction anywhere this time. I have no reactants and no products, and I'm not producing anything. What I do have is some carbon dioxide, which has some oxygen in it. And I know the amount of oxygen, and I want to know the mass of carbon dioxide. So that tells me I have an element that's within the compound. And so if I write out the formula for carbon dioxide, I see that there's in 1 mole of CO2, there are 2 moles of oxygen. Just picking that up from my coefficients, my subscripts. So I'm going to need to use that relationship. Right now, the question starts me off with 2.70 times 10 to the 25th atoms of oxygen. Now, atoms should clue you into Avogadro's number, because that's the only conversion we have that will allow us to convert out of atoms into anything else. So 6.022 times 10 to the 23rd atoms of oxygen are equal to 1 mole of oxygen. That allows me to cancel atoms of oxygen. And now I can use my mole to mole ratio that I have up here. 2 moles of O is equal to 1 mole of CO2. That allows me to cancel moles of O. And then last, I go back and check the problem and ask me for what is the mass in grams of the carbon dioxide. So I have one more step, which is to use the molar mass of carbon dioxide, since it's asking for grams. And the molar mass of carbon dioxide is 44.01 grams. Put that all into my calculator, and I get 987 grams of CO2 as my answer. So let's check what we did here. We have, using Avogadro's number right here, because we had atoms given to us in the problem, atoms would have to be, or particles of any kind, would have to be specifically mentioned in a problem for us to use Avogadro's number. Then I had the mole-to-mole ratio found from my formula, so the ratio of an element to its formula, and then finally a molar mass to go to grams.